Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about the better way of visualizing black holes, and this is by something called the Penrose Diagram, made up by Roger Penrose. So we could try drawing this little diagram and quickly draw, and it's not like too pretty or anything, but let's hope it makes some kind of sense. So this is essentially the kind of basic Penrose diagram, very basic. And in here, going upwards, we have a time. So in here, this point, it has infinite future in this very point. In this point, in the very center, we have the current moment. So here and now, whatever we are talking about with this Penrose diagram, this point in the very middle here, which isn't actually in the middle in this one, but let's imagine it's in the actual middle. This one represents the starting location. Like if I would make a Penrose diagram about myself or whatever, then this would be where I am right now and where I am in time as well. So right now, right here is this very spot. If we go this way, for example, or this way, it doesn't really matter, then that's space. So this here represents infinite distance, somewhere infinitely far away. And now another interesting thing about Penrose diagrams is that light can move in these diagrams in 45-degree. That was not a good 45-degree angle. Light can only move in 45-degree angles on this Penrose diagram, and this is really important. So I'll try to draw something a bit better, so we could have a kind of a better grasp of what this actually means. Okay, so in this kind of starting point that we have here, I really should have different color markers to make it clear, but everything else is the same. Like this is time, this is distance, but here when we start, then this is what we call a light cone, and it extends into the past and into the future as well. And essentially what it notifies is any interaction that can be had in our universe, in our world, in space-time. So in here it represents anything that could influence, if we're talking about me right now, for example, anything that could influence me right now in this point right now has to be in this light cone. If it's too far away somewhere else, then there's no way it could have gotten to me, even at the speed of light, to where I am right now. So no way that anything in this kind of space could influence really anything about my existence. Same way if we look to the future, let's say that something is like really far away, like we have some kind of galaxy that's like 1,000 light years away, and let's say it's here. So this light cone is always moving at a 45-degree angle at the speed of light. So I could not reach this place, even moving at the speed of light, by the time that it's like this kind of time. I hope that makes some kind of sense. I will make a new diagram since this is getting really messy. And this is kind of basis that's really interesting about really actually understanding about black holes, the fundamental aspects of black holes and what they mean. So, okay, so in here we have a slightly modified sort of schematic, and in here it's still the same Penrose diagram. In here it's infinite distance, and in here it's infinite time, and in here it's infinite past. And this one we could have a black hole. And so it's interesting when we start thinking about these 45-degree angles, these light cones that we've been talking about before, essentially how they could move and how interactions could work in space-time. So let's say that I'm somewhere near a black hole and my light cone is like that. And so we can already see that a part of my future is inside the black hole. So there is less of a future available for me where I'm not ending up inside the black hole. And we could see this really easily. for example, by something like this, where it's already a lot, you're getting quite close to the event horizon of the black hole, and so your light cone is almost entirely inside the black hole. So the future where you could be and stay in the outside universe is getting smaller and smaller. In here, there's still a little bit of chance left that you could escape the black hole. But if you keep going in that direction, there is no way you could get out. And then we could imagine this kind of, ultimate light cone, or whatever you want to call it, that has passed the event horizon. And in here, this is where this Penrose diagram becomes useful, because we can visualize it in an interesting way. And in here, looking at these light cones, how these things sort of represent space and time. In here, we can see clearly light can move at 45-degree angles. This is the event horizon of the black hole. And in here, once you pass it, your future light cone, the only thing in your future here is the event horizon, is the singularity of the black hole. So once you pass this point of the event horizon, the only future you can have, extending this out to the future, no matter if you try to accelerate, you can go close to this line here, but you would still end up at the singularity. So this is a kind of really useful visualization of how this Penrose diagram actually works, and it kind of in an interesting way gives intuitive kind of sense about black holes in a way, and it's a lot of different things we could do with this. So yeah, interesting to look at this light cones, like they all have a past and the future as well, and in here the only future is the singularity. So this is just like the very basics of what a Penrose diagram is. It's fun to think about it, having maybe black holes connected with a wormhole or something like that, or with like two different universes and a black hole in the middle. It's all kinds of interesting and fun things that can be explored with this diagram. So but this is just the basics. Hope you got something interesting from this. Thank you so much for watching, and take care.